A number of independent lines of research depict the universe, including the social organization of living creatures, which is of particular interest to humans, as systems, or networks, of relationships. In physics and philosophy, a relational theory is a framework to understand reality or a physical system in such a way that the positions and other properties of objects are only meaningful relative to other objects. In a relational space-time theory, space does not exist unless there are objects in it, nor does time exist without events. Space can be defined through the relations among the objects that it contains, considering their variations through time. The relational point of view was advocated in cosmological physics by Gottfried Wilhelm Leibniz, Ernst Mach, in his Mach's principle. Although Albert Einstein was impressed by Mach's principle, he did not fully incorporate it into his general theory of relativity. Several attempts have been made to formulate a full Machian theory, but none has as yet succeeded in gaining broad acceptance. Basic physics has assumed and characterized distinctive regimes of relationships. For common examples, gases, liquids, and solids are characterized as systems of objects which have among them relationships of distinctive types. Gases contain elements which vary continuously in their spatial relationships as among themselves. In liquids, component elements vary continuously as to angles as between themselves, but are restricted as to spatial dispersion. These systems of relationships, where relational states are relatively uniform, bounded and distinct from other relational states in their surroundings, are often characterized as phases of matter, as set out in this encyclopedia in Phase, Matter. These examples are only a few of the sorts of relational regimes which can be identified, made notable by their relative simplicity and ubiquity in the universe. Such relational systems, or regimes, can be seen as defined by reductions in degrees of freedom among the elements of the system. This diminution in degrees of freedom in relationships among elements is characterized as correlation. In the commonly observed transitions between phases of matter, or phase transitions, the progression of less ordered, or more random, to more ordered, or less random, systems is recognized as the result of correlational processes, e.g. In the reverse of this process, transitions from a more ordered state to a less ordered state, as from ice to liquid water, are accompanied by the disruption of correlations. For example, atoms are fused in suns, building up aggregations of nucleons, which we recognize as complex and heavy atoms. In life, a variety of molecules form extremely complex dynamically ordered living cells. Over evolutionary time, multicellular organizations developed as dynamically ordered aggregates of cells. Multicellular organisms have over evolutionary time developed correlated activities, forming what we term social groups. Ordering processes have been tiered through several levels, reaching from quantum mechanics upward through complex, dynamic, non-equilibrium systems, including living systems.